Let's have a look-see at the Milwaukee M18 Fuel Wet Dry Vacuum. This is the 6-gallon single battery edition, and I've had this unit for about 2 years now, and I figure it's a great time to do a review. In this look-see series, I start off with a grand overview, kind of the externals, how the functionality works, and then I take it apart and we'll see how it was made inside. I got to take this apart now because, well, I did something kind of fuelish here. I was cleaning it up. I had a bit of a dirty job, and I was giving it a clean up, and I blew some air here from this air blower into the motor, and well, there's a little filter in there, and I kind of blew that filter in. So PSA, public service announcement: don't blow compressed air into there, otherwise you'll dislodge the little filter. Anyways, we're going to take it apart, and then in the third part of this video, we're going to run some tests on this vacuum, and we'll see how it performs. Now, ordinarily, your vantage point is going to be from above, just like this, so I'm going to talk about externals from a top-down sort of a view. Let's have a look at how we operate this vacuum. Here is the battery slot, and when you're from above, you stick the battery in here. Occasionally, it's a little bit of a pain in the butt, but not too bad. This here is a high-output XC 8.0. I quite like these batteries in this vacuum. I have 2 of these, and they're always fully charged. And, well, frankly, I've just never ran out of power. I run the battery down until maybe 1 bar or so, and then, well, just swap it out. And I've never had a problem with battery life. Just stick it in like so. Now, what else do we have here? We got the power switch, and the power switch is shrouded with this rubber guard that prevents dust ingress. Very nice to have. Unfortunately, a lot of these dust-guarded switches, they're kind of mushy and they don't feel good. But this one here, it does have a nice clickety-clackety action, and I don't have any complaint about that whatsoever. Now, what else can we look at here? We got these little tie-down points, and these tie-down points, you got 4 of them on each side. And Milwaukee does offer a couple accessories for these. They have a bag for accessories. I had one of those. I got rid of it. Don't need it. They do now have the what do they call it? The particle isolator. I don't know, the thing that separates the larger items from the smaller items and prolongs the life of your filter in your bag. That can clip onto here as well, which is kind of neat. I'm thinking about getting one of those. However, if you were to get one of those and have the single battery vacuum, you're going to be forfeiting the onboard storage here for the nozzle. Yes, here's the corner nozzle, as well as a floor nozzle, which is very convenient to have it in there like so. And nonetheless, it's a little bit of a well that's going to collect dust, and I just gave this a vacuum, a cleaning, like I said. Yeah, it was pretty gross in there. Anyways, what else can I say? We got here an outlet, and I'm going to give this a test a little bit later on in the video. We're going to see just how much air this outputs and whether you can actually use it for anything useful. It's on a wheelie base, and the wheelie base can be separated with this foot pedal. You lift it off, and it's not too heavy. In fact, you can lift this off and you can carry it out to your automobile and give your car a cleaning, or on site, something like that. I do that fairly regularly. At the moment, this thing is full of concrete dust and gravel and shit. It got to weigh 40 pounds or so. Ordinarily, the entire unit, that's about 26 pounds, and just the top unit, I think it's around 15 pounds or so. It's not too heavy. Anyways, you might notice that my setup here is a little bit different than stock. Stock, it comes with this 9-foot octopus monster hose. It's a great hose, but I find it a little bit awkward. What you got to do with it is you got to stow it around the top of the unit. It has this clip that helps hold it into place. However, on the back side, you use this elastic that screws on to this bracket here, and it holds the hose. You can check out their webpage and you can see how that works. I don't like it. I think it's kind of kludgy. It's effective, I guess, if for the stock hose, but my preferred solution is to use the expandable hose. Check this puppy out. You can expand that out to quite a bit longer than in its stowed position. And its stowed position, I have it with one of the extensions and stuck here into the crevice nozzle, and it's just way, way neater and easier to carry around. Even when you lift the unit off of the wheelie basin, you can carry it out to your car. So much easier. When you're actually vacuuming around the floors, you can just drag it around by the base. It's actually pretty convenient, in my opinion, to use, much more so than the stock hose. Now, another one of my additions to this vacuum is ordinarily the long hose would wrap around the top and would fit into this bracket. I'm using this bracket instead for, I think they call it the curved nozzle. Alternatively, these are known as car nozzles. I like these ones here. It's my most grabbed nozzle here, and what it is really useful for is spot cleanup, as well as getting on top of your workbench and slurping up all the crap there. Yeah, I quite like this. This here I consider it an essential necessity, and just clip it on there is really convenient. On the rear side of the base are some of these receptacles that can take various additions. For instance, here's an extension hose that comes with a vacuum, and in addition to that, I got a couple brush tools, a floor brush, and I haven't really used those too much, but they'll definitely come in handy occasionally. Well, anyways, let's get into taking this apart and well, see what's inside. Well, let's just start with taking the bag out. Like I said, this vacuum is fully laden, and I did a lot of vacuuming of concrete dust, so it'll be interesting to see how well the bag did in keeping. I got the HEPA filter installed, so let's see how that's going to be. Well, there's the bag, and there's the filter. The filter is really clean, actually. Those vacuum bags are bloody expensive, but they really do work. And this vacuum, it still has a bit of space in it, but yeah, like I said, it's about 30 pounds of concrete dust in there. Look, let's check that out. Anyways, it does a remarkably good job of keeping the interior of these units. The chamber is practically sparkling. Anyways, here is the bag holder, utility, nothing really too interesting there. And now that we got that weighty bag separated, we can take this bucket off and have a little bit of a closer look at it. There's the water drain. Get rid of that. And let's see what sort of markings we can see on it. Has some rubber feet. That's kind of a nice little touch. Has some rubber feet. And I'm not seeing where the plastic type marking is. I'd imagine that it is similar to the M12 vacuum that I looked at before. What was that? A talc? I think it was talc-filled polypropylene? I'm not sure. Anyways, it's some sort of fairly rigid plastic. And, yeah, well, that's the base there. That's the dust cavity. Here is a view of the base, and you can see it has locking casters on all four casters. That's kind of nice. Anyways, now let me get the power unit up onto the bench, and we'll take that apart. And here's the underside of the power head, really clean once again. Little bit of dust here, but not too bad. HEPA filter installed, twists off like so. And we have the float cage and a whole bunch of Torx T15 screws. Let me undo a whole handful of these and bring you back. And so there's the float off, and we can see some plastic markings finally. It's PPCP for polypropylene copolymer. Basically, it's a molecule made up of polypropylene and polyethylene units, and it's somewhat of a plastic in between. Stiffness of polyethylene and some of the resilience of polypropylene. Kind of interesting. This here is the business unit that is taking the air in, and we got a gasket around here that would be for the air filter, and a rubber bumper, I guess, that make a seal if this float was to float up to the top. The fan looks like it's made out of stainless steel, and just for fun, I stuck a tachometer tape on there. Let's see how bloody fast this thing goes. You know it's going to be spinning 1,000,000 miles an hour. Here is at speed level number 1. Little over 35,000 RPM. That was just level number 1. Try number 2 now. A little over 40,000 RPM. Don't stick your fingers in there, the blades are pretty sharp. Anyways, let's take the rest of the screws off and see what's inside. More than a dozen screws later, we have access to the inside. And let's flip that over, and we got the blower housing here, as well as the fuel, Milwaukee fuel brushless motor. I thought that fuel motors had red plastics. Well, not so in this case. Has a label on it. The label has some part numbers and says also 18 volts DC, made in Slovenia. Interesting. 3 wires to it, pretty beefy wires, 3-phase type of motor. These wires, they're quite supple. And they're labeled, there's silicone rubber insulation on these wires. That's kind of interesting that they're doing that. Here's a plastic marking. The plastic marking says PP plus TF30 polypropylene talc filled 30%. That gives polypropylene a little bit more stiffness. Ordinarily, polypropylene's a pretty flexible, soft sort of plastic. Let's move that aside and have a look at the electronics. Here's that foamy thing that I mentioned earlier in the video that's fallen out. Honking huge heatsink here. I don't see any active fan cooling, however. It's a pretty big airspace nonetheless, so I guess that's adequate. This wire here, it seems to go to the central shaft of the motor and then to the metal cage around the fan. So that must be for static dissipation. A little bit unusual that it's not eroded in any way. It's just kind of flopping around in the wind like so. Otherwise, there's not a whole lot to see in here. Let's just see how that foamy is going to fit into place. I guess it just slides in like so. Oh, no wonder that blew out so easily. There's like hardly anything holding that into place. Yeah, so I remember to not be blowing in that vent in the future for cleaning the vacuum out. Anyways, let's put it back together and run some tests. Now, the first test is going to be a simple, will it pick it up? I got a variety of stones here that range from fairly small all the way up to, well, what is pretty close to the maximum size that this 1 7/8 inch hose will accept. Test conditions are a HEPA filter installed, good condition, not new, but good condition. You saw it earlier in the video. I put in a new Milwaukee branded Fleece vacuum bag. I got a high output 8.0 battery in there. The hose is the stock hose, not the accordion hose. And for extension wands, I have both of them attached for floor duty, as well as the utility floor nozzle. And we're going to try picking these rocks up on speed level 2. That worked. That worked. That worked. That worked. That worked. That worked. And the biggest one. The vacuum had no problem picking up any of those stones, even the maximum size. So this vacuum could pick up pretty much anything that'll fit in this hose pretty well. Now let's get empirical and see if we can verify Milwaukee's stated claim of 87 cubic feet per minute of airflow. Now, in order to evaluate this, I have no longer the extension nozzles, but I got this 2.5-inch dust port adapter and a wind speed meter. And you get this turned on and set it up to feet per minute. Put it on maximum mode. Once again on high power. And we get a wind speed of 3,007 feet per minute. And we can calculate cubic feet by taking, well, the area of this diameter, multiply it by this number, gives us cubic feet. And I find an airflow of almost 103 cubic feet per minute. That compares really quite well to Milwaukee's stated claim of 87 cubic feet per minute. Presumably, Milwaukee is being a little bit conservative because, well, maybe they're measuring it over an entire duty cycle, and as the tank is from empty to full, maybe they're using a smaller battery, something like that. Whatever the case, kudos on them for being a little bit conservative with those statistics. Cubic feet per minute airflow, that is important for getting stuff through the hose up and into the dust chamber. But what's also very important in measuring the performance of a vacuum is its ability to generate negative pressure, or its vacuum potential. Milwaukee claims that this is able to develop 60 inches of suction, 60 inches of water suction. Now, I don't have a gauge in water suction, but I do got this vacuum gauge here. I got it on Amazon for under $10. This here's measuring in inches of mercury, and, well, it's not too difficult to convert from one unit to the other. So once again, power level 2, and let's see how many inches of mercury this vacuum is able to develop. Negative 5 inches of mercury, that translates to about negative 68 inches of water pressure. Milwaukee claims 60 inches of water pressure, so let's test this out. I have this vacuum set up on the stairwell, and it's around 64 inches of height. Now let's go down here to our test bucket, and if I can get my lovely assistant to turn it on to power level number 2. So this vacuum has plenty of suction at the inlet. That must mean that it's capable of producing some pressure on the outlet. I have this hose now connected to the outlet, so it's going to be acting in a blower type of configuration. Now, clearly, you're not going to use this blower on the vacuum for, I don't know, blowing leaves or something like that. The amount of airflow is just way too small compared to a leaf blower. However, that centrifugal squirrel cage fan, that's capable of generating a pressure differential, a vacuum at one end, pressure at the other. And if you put a reducing nozzle on, such as this one that comes stock with the vacuum, this is able to put out some really high-speed air. That might be useful for certain jobs like blowing out filters or maybe dusty electronics or something like that. So let's evaluate the wind speed that this vacuum can develop on the outlet. I have a Nemo meter, a wind speed meter, and I'm going to measure it at 4 inches. 4 inches because if you stick it right up to the schnozzle, it just goes over the maximum. I think it maxes out at 100 miles an hour. So let me put the vacuum on in speed level number 2. This is set at maximum recording, so let's give it a try. and it overloaded anyways. Okay, so it is capable of producing a wind speed greater than 100 miles an hour at 4 inches. It's funny, I tried it just before I did this video recording, and I got about 78 miles per hour at that instance, but I guess it's just the exact anglage that you get on the wind speed meter. Now, let me reset this here and put it back into maximum mode. And let's check out a different option for blowing. This here is an Oh Yes, I hear that all the time, Oh Yes branded Amazon special from China. It uses Milwaukee batteries as well. I got an XE 5.0 here. I use this all the time. It's on my bench, and it's great for creating a concentrated stream of air. It's not really a replacement for an air gun and an air compressor, but it's actually a lot more convenient than that vacuum outlet. That vacuum outlet, the hose is kind of even my accordion hose is a little bit awkward to use. This is just way more convenient. So let's do the same test at 4 inches with the Oh Yes. And the Oh Yes makes 79 miles per hour. And what we can see is that this vacuum in a pinch can be used, well, for blowing tasks, at least for concentrated air. Now, for the last test, let's check out power consumption by this vacuum. I got a high output XE 8.0 battery here hooked up, and this is monitoring real-time battery voltage, and this is monitoring how much current the vacuum is consuming. Let us begin with speed level number 1, and I'll let it run for maybe 30 seconds or so to stabilize. Okay, that's speed level number 1. Now, let's do speed level number 2. This time what I like to try is wide open as well as obstructed. I'll let it stabilize wide open, and then I'll put my hand on the inlet. Interestingly, what we notice there is that the vacuum is actually using less power when it's obstructed. That's kind of counterintuitive, because when you obstruct the inlet, it sounds like the motor's working harder, but it's actually not. You think about what this power head is doing. It's taking battery energy and converting it into air movement, kinetic energy of air moving, and, well, if you block the inlet, that means that no air is moving, or at least less air inside the squirrel cage fan. So yeah, less air moving means less power consumed. And I calculate that this vacuum uses about 265 watts on speed level number 1 and around 350 watts on speed level number 2. Now, how can we use this information to determine runtime? Well, you could have read the amps being drawn, and you do a little bit of arithmetic with the amp hour rating of the battery. A little bit more accurate would be to turn the battery over and read the fine print and see how many watt hours the battery has. These high output 8.0s, they have 144 watts. The 12 amp hour batteries, those have around 216 watts, and that's what Milwaukee is going to be using for its claimed estimate on the product specification page. They claim a runtime of 31 minutes on high power, speed level number 2. By my estimates, this vacuum might run as long as 37 minutes, a little bit longer than Milwaukee's claimed runtime. On speed level number 1, Milwaukee claims a runtime of 47 minutes, and I estimate that it could run potentially for 49 minutes. Anyways, I hope that you enjoyed this look-see at this Milwaukee wet dry vac. Subscribe, and I'll see you next time. Bye-bye.